Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore another very important vector database, and that is FAISS or Facebook AI Similarity Search. So while discussing vector DB, we have already encountered two varieties. One is Pinecone and another one is if we are having already one PostgreSQL RDS instance in our AWS cloud, then we can simply install pgvector extension in it and we can convert that traditional transactional RDS Postgre instance to a vector database, right? So on these two vector DB, I have already explained in detail. If you want to know those detailed explanations, you can check the link given in the description box in the prerequisite section. Okay, so just a quick recap. Initially, we started with Pinecone, but we understood that there is one issue, that Pinecone is kind of a third-party storage system. So many organizations might have compliance issue like HIPAA compliance or any other compliance problem, and due to which they might not be interested to send their data outside AWS infrastructure. Okay, but because their Pinecone is sitting outside, so maybe Pinecone may not be a very preferred choice for many organizations. So that time we can opt for pgvector if we are having some PostgreSQL RDS up and running. But if suppose we don't have any existing running PostgreSQL RDS, so that time is there any alternate lightweight vector database to work with Python and solve the similarity search related use cases that can be classification, clustering, etc. etc. And the answer is yes. That time this FAISS comes into picture. Okay, so FAISS you can consider is a very lightweight Python module which can act as a vector database. We can put our embedding vectors in it, and for some unknown test vector, if we want to search quickly that what are the top 5 most similar vectors available in this FAISS DB, it will help us in getting that particular data very quickly. So kind of k nearest neighbor only they are implementing in the backend in a very efficient manner so that it can give us the nearest neighbor vectors very quickly, right? So I hope you understood this fundamental theory related to FAISS. Now quickly let me go through their original documentation and which you will be finding here. So here if I scroll below, you will be getting the definition of FAISS or Facebook AI Similarity Search, that it is a library for efficient similarity search and clustering of dense vectors. For our text embedding vectors, we can store it and perform clustering similarity search related problems we can solve using this FAISS library. It contains algorithms that search in sets of vector of any size up to the ones that possibly do not fit in the RAM. Okay, so in short you can understand this FAISS might not be very good vector database choice for very big embedding vector storage, but for low to medium size embedding vector storage and performing similarity search and clustering without any major overhead, this FAISS can be a good choice. Okay, right? Now in this video we are going to explore how we can store embedding vectors in FAISS and perform similarity search. So to do that, here I have taken some data. So here if you see, the data is basically list of list, and in each list, first element contains some text and the second element is basically defining the category of that text. Like what is the capital of France? This is a geography related thing. What is the tallest mountain in the world? This is another geography related thing. And then there are some technology related topics, like how does quantum computing work? This is a technology topic. Cyber security, this is another technology topic. Then there are some texts which are belonging to science, like theory of relativity, in our solar system, how many planets are there, what are the planets, etc. etc. Who discovered electricity and all, right? Let's consider we are having this particular data frame. So let us quickly create that. And here I'll be installing also the required modules eventually. Keep install pandas. Here you can see it's thrown an error, name PD is not defined. So here we need to install pandas first, and then here import pandas as PD. Okay, so install it, and then we can run this particular script. So here it ran successfully. Now I can do df.get to get a view of our data frame, and here you can see we are having text as first column, category as the second column. And now suppose we are getting an unknown text, that is what is the largest ocean in the planet Earth. Obviously we can understand by reading this particular sentence itself that it is belonging to geography category. But using similarity search we need to find out. So what is the flow to solve this particular problem? As a first step, for each of these text we will be getting its embedding vector and will be storing in our vector DB, and then for this unknown text for which we want to classify to a particular category, for that also we will be getting its embedding vector, and we will be finding out in our vector DB which training vector that is out of these data points which is most similar with the embedding vector for this query, and that vector which is most similar with the vector representation of this text, for that one whatever the category will be having, that is nothing but the category for this test data as well. That way we can classify category for this unknown test data, right? So that same process what we followed in our previous video using pgvector, same pattern or the same pipeline will be following in this particular problem statement as well. Okay, so I'll be opening my previous video code. So here as a first step we downloaded and unzipped our test and train files, but in this video we are not going to use those BBC News related files. We have our own test and train data. So I'll scroll below, and here as a first step we are importing all this. So I'll just do that in the import tab. Pandas as PD have already imported. I can delete this one, and this one we were basically using to interact between Python and PostgreSQL. That is not needed in this, so I'll delete that as well. Now sentence transformer we need to install. So let's see the install statement. Here, let me copy this from here and paste that here. So sentence transformer and pandaral we are using. So sentence transformer is needed for each input text to get its vector representation, and pandaral we are using to convert this text column to embedding vector in parallel manner. Okay, right? And apart from that, in this video we are going to use this FAISS Vector DB, right? So for that we need to install FAISS-C. So it supports two things, CPU, GPU, because we are doing a simple POC, so I am opting for CPU. And then I will do this POC installation. Let it get installed, and then here we are installing the sentence transformer. Now for embedding we require a model, and here in this video I am going to use the same model what we used in our previous section, that is all mini LM L6 V2. So that I'll be putting somewhere maybe here. Okay, and then let's go back to our earlier code. Here we are reading the data, and this particular function we need to put, which is basically taking the text that can be from training data or test data, and it is converting to its vector representation. So I'll be copying that, and maybe I'll be pasting that somewhere here, right? And then as part of the next step what we are doing, we are initializing pandaral with 8 worker nodes. So the same thing I'll be following here, right? And then here we are getting the embedding vector representation. So I'll be putting that, and then maybe here df dot create I can apply to view whether text embedding happened or not for our input text. Okay, right? So as part of the next step here, if you see, we are basically executing insert into command to insert those embedding vectors in our PostgreSQL RDS. So from this step the process will differ, because this time we are going to use this FAISS, right? So maybe let's see how to code it. So here some tutorials are there, and in tutorials here C++ or Python option is there, so I can opt for Python, and the simple example is available 1-flat.py, so that one I can choose. Okay, so this code we can refer to understand how to insert our embedding vectors in FAISS DB. So we'll do that, but before that let's complete the embedding process. So here all this installation is done, and now here we will execute this particular place. So here it is going to take some time to import sentence transformer, because it is a huge package. Let's wait for a few seconds, and yeah, it is done. Now we will define our model. It is going to download some important components, and here you can see it is downloading, and it is done. Now here we are defining our training data frame, and this is the data. Now we are creating our embedding function, and then here we are creating pandaral with 8 workers, and we are running the generate embedding function on our test column. So here if you see, we are having this text column. So we may be renaming this was capital T, but in our data frame it is small t. So I'll do that. And then here you can see it started in parallel thread. It is done because it is a very small data set, only 910 records are there. So that's why it happened quickly. And now if I do df.head, here you'll be seeing one new column is added, text embedding, which contains the vector representation for our input text. Okay, right? Now as a next step, we need to insert all these embedding vectors in FAISS DB. So let's go back to the code which they have given in the tutorial, and let's understand what they have done. So here they are inputting numpy as np, and they are working with 64 dimensional data, whereas in our case we are working with 384 dimensional data, right? Because in our previous video itself we have explored that this particular model convert any input text to a 384 dimensional dense vector, right? So that one we need to change. So dimension in our case 384, and database size NB. So database size is basically equal to amount of our training volume. So you can understand they are considering this much training data, right? And the training data they are generating as a random vector using np.random. And here maybe they are normalizing or standardizing some process they are doing. And then in this particular paragraph, they are inserting those vectors in the FAISS Vector DB. So first they are importing, and then they are building some index, and then they are adding their vectors in this index or vector DB, right? So maybe I can copy this particular code and I can paste it here somewhere. So here embedding is done. So here I can paste it. Import FAISS, we are doing the import. So this import should work properly because here we have already installed FAISS CPU, right? So we will not face any problem. And then here index flat L2. We are building the index, and here we are putting D. So D is basically dimension of the embedding vector. So in our case it is 384. Okay, right? I am hard coding it. If you want, you can put in some variable and use that variable here. And this thing is not needed. And then as part of the next step, they are adding the embedding vectors in this index. So maybe that one I can put in a separate code block. Okay, so I can execute this cell now, and here it is done. Now they are adding XP. XP is their embedding vector. So in our case, the embedding vector is basically df of text embedding, right? This column we need to insert in the vector DB. So let's see whether this syntax will work or not. And it shows some error. It is returning not enough value to unpair. So what is happening, we'll explore. So one easy way to understand is take their example and let's see what pattern they are following to provide input. So maybe from here to here I'll be copying it because this XP they are directly adding, right? So we need to understand the format of XP so that we can pass our embedding vectors in same format. So I can put this one, and then maybe here I can execute XP to understand their data format. Okay. So here if you see, this is the way how they are ingesting the embedding vectors. So what is happening here, if you observe here, one array is open and here our list or array is closed. Okay, so this whole thing is one vector. Then here another array is open, here the array is closed. So this is another list or another vector. Like that way, here all the vector lists are available, and outside this is basically within a particular vector. So it is nothing but array of array in NumPy, that kind of data type they are following to insert the data in FAISS. So FAISS is expecting in this particular format. But in our above code, what format we are following, if you see, here we are trying to insert one pandas column as a series. Okay, but this should not happen. We should be converting this particular pandas column or pandas series to array of array, and where each inner array element is basically our embedding vectors, right? So that kind of code we need to write. If you want to write using AI, you can just click on explain error. It will give you the updated code. Google Colab is intelligent enough to do this correction. So here it is thinking. So here it has given some suggested change, and it looks like this: np.stack, and then they are taking our data frame column, they are converting to list. Okay. So if you check the explanation, the error valuator not enough value to unpack in this context usually means you are trying to unpack two values from something that yields only one, right? And that is obvious. In our this data frame we have only one series, but index.add is expecting array of array, right? So unpacking is failing. In this case, index.add method expect numpy array of set n, d, where n is number of vector, d is dimension of each vector, right? The error suggests that df text embedding might not be the expected format, possibly a single vector instead of a 2D array. So that's what I just now said, instead of 2D array, we are sending a pandas series or pandas column. So this particular code will convert that pandas series or pandas column to array of vectors, right? So here I have updated the code and now hopefully it should run. So here it is executed. So now this particular section is no longer needed. I can delete this. Just I used for understanding the input data format. And here it is done. So if you see NP was not defined or defined, I am not sure. Let me define it to avoid any confusion. So I'll again declare, and on the top I'll be defining the import numpy as NP. And then I'll be executing this particular index.add, right? So it is added. Now our vector DB is ready. It has all the training embedding vectors. Now it's time to convert this test data to a vector and try to find out similarity. Okay. So here we are having our query. So as a first step, what we'll be doing, we'll be getting its vector representation. So here I can give vector test data equal to, here if I put a tab, Google Colab itself given the suggestion that using generate embedding function, which we have already defined here on the top, this one, the same function we can utilize to convert our test data to embedding vector, right? So that one we are doing here. And here if I now execute vector test, here we are getting one numpy array again, and this is a single array, right? 1D array if you see. Okay, cool. Now let's see how to do similarity search in this FAISS DB, what they have written in the example code. So for that, here they have given some example how to do similarity search. So to do that, we need to execute index.search. Okay, if you observe, first we need to define k equal to 4. So k value is defining top 4 neighbors or top 5 neighbors, how many nearest neighbor you want to find out from our vector DB. So here 4 means 4 nearest neighbor we are trying to look for. Okay, and then we need to execute index.search. We need to pass our test vector, the number of nearest neighbor we want to look for, that k value we need to pass, and it will be returning d, I, where d is basically distance in ascending order. That is, the first distance will be minimum, then we'll be having that vector which is a little higher distance, then another vector with little more higher distance, like that way in ascending order distance will be there. So we can say the vector which is having lowest distance or highest similarity will be in the beginning of this D array. Okay, and I will be giving us the index position, that in our training data this particular index or this row is having that highest similarity. Okay, so that order it will be giving us. So I can copy this particular section and I can execute. So here vector.test I can replace with this code. So to easy understandable purpose, here I can give distance and index position. Okay, right? So index, because here in our vector table we have defined the name index dot search, and k is 4. Maybe here in this case I want to find out top 3 nearest neighbor. Let's consider. And here they have given their test vector. Here we need to provide our test vector. Okay, vector test. So here if I run, let's see whether it is giving us top 3 most similar vector or not. And no, it failed. Okay, not enough value to unpack. So again that same issue, right? So what is happening, that when we want to perform similarity search with FAISS DB, then the test vector whatever we need to put, that also should be array of array for numpy data type. Okay, it should not be a single numpy vector or numpy. So to convert that, they have suggested this particular reset function. So I'll be using that vector test.reset. Maybe here itself I'll be writing. Okay, right? and then here I can execute this one. And hopefully it is done. And now if I execute distance and index position, here we will be getting the distance. As I told you, in ascending manner we will be getting the first index is having lowest distance, and the index in our training data frame which is having lowest distance is index 7. So let's go to the index 7. So here we are having this data. We are using simple df here, and 7th index element, let's see. And here if you see, the category is geography, and in our query it was here, what is the largest ocean in the planet Earth. This is also nothing but related to geography only, and that's why when we are converting this test string to embedding vector, it is finding the highest similarity with row number 7, because it is also kind of related to geography, what is largest desert in the world, right? And then the next indices, what it has returned 9 and 5. If you check row number 9 in our input data frame, row number 9, what is the circumference of Earth? This is also related to geography. And row number 5, if you see, what are the planets in our solar system? This is related to science. So this is little bit misclassified, but maybe we are more interested in that particular category which is having highest similarity or lowest distance, right? So that one we can easily derive from here. So to find out the category for this unknown text data, what we can do, from our training data we can take the category. This is basically defining complete column. From there we need to take the category value for that row which is having highest similarity, and that is available in this index position array, right? So we can take index position of 0. So here if you see carefully, it is an array of array. So first we need to extract this particular array set using 0, and within that the 7th index, this is basically indicating in the 7th position in our training vector, whatever data is available, that is having highest similarity. So that's why I am using index position 0 of 0. Okay, and that one maybe we can put within one particular square bracket, and if I execute here, then we will geography, right? So this way we can find out for any unknown text data what is the category using FAISS Vector DB. And even when you are working with large data set, you can do join and play with it. For example, currently here we are having distance and index position. From that I can maybe create a pandas data frame, pg.data frame, and then here we can put a dictionary where the first column is distance and the second in the index positions. Okay, right? And distance, to get that, here distance is basically our variable name. Here I'll be putting that, and here if you see, the data points what we want to extract is this, but this is within one external array. So I'll be putting that as 0 like this way, and same goes for index position. Now if I do result data, all arrays must be of same value. Okay, so here we need to provide the name, that is index position, that is this particular array is belonging to index position, right? So that one we are extracting, and we are getting the result data like this. Now we can join this with our input data frame. So merged data equal to pt.merge, and here if you see that Google Colab itself is giving some suggestion. I can just click on tab and then explain the code. So result data is basically our this particular data frame which contain the distance and the index position, and 3 rows it has returned because we tried to find out top 3 nearest neighbor. Here it should be 3, right? So that's why 3 distances or 3 rows it has returned, and where top row is basically lowest distance or highest similarity, then second most similar item, then third most similar item. Like that way it has gone, and this data we can join with our training data set, and the column on which we should be doing join, that is in the result data, index position should be the column, and in our right data frame, which is basically our training data, in that data frame we need to join with respect to index position for our training data. So right side data frame, for that we are considering right index. That means it will be considering the index like that. And now if I execute merge data, here beautifully it will be returning the result. So here if you see, for our this unknown test data, the highest similarity it is getting with category geography. That is, what is the largest desert in the world. Then the next highest similarity, what is the circumference of the earth. Then the third one, what is the planets in our solar system. It is belonging to science, kind of this classification. But if you check the mode of this category column, obviously geography is the category in which our input text is getting classified, and that is our correct pass, right, for this particular input text. Okay, right? So this is how you can play with joins and many other things, and this is how we can work with FAISS Vector DB, and this can be very useful if you are working with AWS in serverless world also. So generally, often this particular pattern is followed, that once our FAISS vector database is trained, what we can do here, if you see here in the index, all the training data or our vector data is stored, right? So we can have a dump in some S3 location, and maybe for any unknown test data whenever will be coming, we can maybe have a lambda here which will load this particular vector database in runtime and use that particular vector index to classify our input test data is belonging to what category by embedding, right? So this is a popular pattern on which I will be discussing in my next video. So I hope in this video you got some idea around FAISS Vector DB. I will suggest you to run all this course, play with it, that way you will be having better idea out of it. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.